Hi everyone, this is Udeme Epo. I'm a chemistry teacher with dolessons.com. In today's chemistry lesson, we'll be looking at hardness of water. Hardness of water is a process in which water does not form lather with soap as a result of the presence of some metallic ions in the water. The origin of hardness. Water becomes hard when it flows over a soil that contains gypsum or limestone. In that process, the gypsum or the limestone dissolves in the water, making the water hard. Okay. Gypsum is primarily soluble in water, while limestone will need the presence of carbon dioxide to dissolve in water. When these two compounds dissolve in water, the water now becomes hard because of the presence of chemical ions from these compounds in the water. There are two types of hardness. We have temporary hardness and permanent hardness. The difference is based on the chemical ions responsible for the hardness. For temporary hardness, the chemical compound present in the water is calcium hydrogen triisocarbonate 4. While in permanent hardness, the compounds responsible for permanent hardness are calcium tetrasulfate 6, magnesium tetrasulfate 6, calcium chloride, and magnesium chloride. Temporary hardness is an easier form of hardness in the sense that heating the water will be able to remove the hardness. Reasons being that calcium hydrogen triisocarbonate 4 decomposes on heating to form a compound called calcium triisocarbonate 4, water, and carbon 4 oxide. When this is heated, this is present in the water as a soluble compound. When the water is heated with this compound soluble in the water, the compound breaks down to form calcium triisocarbonate 4, which is insoluble. Now, since calcium hydrogen triisocarbonate 4 is insoluble, it comes out, it removes the calcium ion from the water, which is responsible for the hardness. So what you now have is calcium triisocarbonate 4, water, and carbon 4 oxide. This is a gas that will easily leave the water. This is part of the water solution, while this comes out as a solid and can be filtered out. So this water can now form leather with soap. This is for temporary hardness. Now for permanent hardness, heating does not remove the hardness because these compounds responsible for the hardness do not decompose readily on heating. So we need some chemicals to remove the hardness from the water. Such chemicals include caustic soda, that is sodium hydroxide, washing soda, which is sodium triisocarbonate 4, then zeolite, which is a resin that can remove the hardness from the water. When caustic soda reacts with these components of water, calcium SO4 in the water reacts with caustic soda, you have sodium sulfate and calcium hydroxide. Now, this does not cause hardness, while this will come out of the water as insoluble. So the calcium ion, remember calcium ion is really responsible for the hardness, will be removed out of the water. When the other component, this same applies magnesium sulfate. If magnesium sulfate is responsible for the hardness, when it reacts with washing soda, you have magnesium triiodocarbonate 4. Okay. This is this. And sodium tetrahydrosulfate 6. And the hardness in the water is removed because the ions responsible for the hardness is removed as insoluble particles from the water. Effect of hardness in water. Hardness in water makes water to be to waste soap because the soap will not form lather with water. It also makes kettles and boilers to have a coating of what we call fours. Causes fouring on kettles and boilers, electric boilers. Since we know that calcium hydrogen triiodocarbonate 4, which is responsible for temporary hardness, decomposes to form an insoluble compound, calcium triiodocarbonate 4. This insoluble material, when you heat the water, let's assume this compound is in the hard water. You heat the water with this soluble compound. When the water is hot, this compound breaks down to form this. When it forms this, which is insoluble, what I mean by insoluble is it does not dissolve in the water again. Good. It comes out as solid and deposits on the boiler you're using to boil the water or the kettle. So continuous accumulation of these results in what we call fouring. If you have electric boilers, you have the inner part covered with fours of calcium triiodocarbonate 4. It also causes what we call stalactites and stalagmites in limestone regions. Stalactites and stalagmites are limestone pillars that grow in caves in the limestone region. The stalactites grow from the roof of the cave, while the stalagmites grow from the ground. And they get to proceed so that they will form a pillar that will obstruct or cover the cave, the limestone region. That's as a result of hard water flowing through the cave in the limestone region. Hard water has advantages, which includes, number one, the calcium and magnesium ion responsible for the hardness are utilized by some animals to build their shells. Animals like snails, periwinkles, crabs, and all the animals that make use of shells that are made up of calcium triiodocarbonate 4. They utilize the calcium ion in the water to build shells. Also, the calcium and magnesium ions are nutritious. So we get to consume calcium ions for improved bones and teeth. And other advantage is that it does not cause lead poisoning. Lead poisoning. If hard water flows through a lead pipe, the lead, that's a component of the pipe, will not dissolve in the water to cause lead poisoning. But if it's soft water, the water will be able to dissolve lead so that when we get to consume the water, we'll have what we call lead poisoning. So it's more healthy for hard water to flow through a lead pipe, although we don't get to use much of that these days. But if we are using lead pipes, hard water will not cause lead poisoning when they flow through lead pipes. Disadvantages of hardness in water. First one is that we cannot use hard water for dyeing because it interferes with the process of the dyeing because of the chemical components that the calcium ion and magnesium ion will interfere with the dyeing process. So we cannot use this. They also cause blockages of pipes as a result of deposition of calcium triisobicarbonate 4. When hard water flows through pipes, if they break down to form calcium triisobicarbonate 4, which is solid, it gets to deposit on the pipe, and continuous flow of the water at a point, the deposition will cause a blockage of the pipe. The other disadvantage is that it wets our soap. If you use hard water to wash, instead of forming leather, it will be forming insoluble particles of calcium or magnesium salts, because the calcium ion or magnesium ion in the water will react with the soap to form an insoluble salt, which will come out as what we call scum. That is unpleasant solid particles coming instead of leather, and they will stain the soap, the clothes. In the next video, we'll be looking at solubility and effect of temperature on solubility. I hope you enjoyed the lesson. Thank you.